welcome distant learners. Ooh, that's volume's kind of weak. Hello, hello, hello. Hello. Good morning. Hopefully you guys are doing well. Make sure you throw your name in the chat so I can know you're here. Sorry, my head is cut off so you guys can see the notes. In the screen, yes. It's like, it's okay, you don't need to see my face, but we are going to jump right into the notes where we left off. We're going to pray real quick, and then we will begin. We'll pray for those prayer requests we prayed for yesterday still. Any other new prayer requests? We have Kylie's aunts and grandfather, Emma's grandmother and grandfather, right? You have an update? Yeah. Where? Just pray for your aunt there. Look at that, perfect timing. All right. Any other prayer requests? Any other prayer requests? No other prayer requests? Welcome, Esther. We're going to pray, and you didn't miss any notes yet. We're just about to start. All right, let's pray, and then we will begin. Dear and Father, Lord, thank you for today. Thank you for the beautiful weather you've given us, Lord. It's going to be a nice sunny day again. Thank you for the students that are here, Lord, the help that you've given us, and the ability for the school to be open, Lord. Please help the students at home, Lord, whether they're not feeling well, whether they're just staying home to be safe, for them to stay faithful in their school, make sure they're watching class, getting their work done, turning it in on time, to build that responsibility in their life, maybe for future things. Please help all these students, Lord, whether they have unspokens or anything. We lift up some special prayer requests to you, Lord. Please help Kylie's aunt, Lord. Obviously, the situation is pretty deep, Lord. Please just help the situation, whatever your will may be there. Please help the family and everything through that. Also, please help her grandfather. As far as I know, he's still not feeling well, Lord. And he's still kind of sick, but he needs to get procedures done. So please allow him to get better quickly so he can get those things scheduled and done as soon as possible. Also, please help Emma's grandmother, as I believe she's kind of going through a rough time with everything as well. Please give her strength through her day. Please help her with everything going on. Also, please help her grandfather, as I believe on the 15th he's supposed to have a heart procedure. Please help him through that, guide the doctors, give them wisdom, give them a calm hand in the work that they do. Please help the family to just have patience and have trust in you, Lord. Again, that your will be done and for everything to go smoothly and quickly for that. Please help everything with that. Also, please help Tori's arm to recover, Lord, whether it's bruised or how it's feeling today. Please help it just to be able to feel better so she can get back to writing with her normal hand. Help her in school. Please help any other students, Lord. Maybe they have unspoken or something going on that they didn't want to share. Please just help them to know that you're there for them. Please help our class today for us to be able to move along and learning about you in this story of the woman at the well. Bless all the kids at home. In Jesus' name we pray, amen. All right, yesterday we were talking about, and the new notes for today that we're beginning are on the screen, but yesterday we talked about what specifically? Okay, yes, but like we talked about, we had like an introduction, okay? That part is more like self-explanatory. He went from Jerusalem to where? Samaria. Sychar is the place, okay? Is that very usual? Okay, usually they go all the way around. Okay, we also talked about the place and the people. Okay, there were a few main notes with that. I'll go back to those just so you guys can see. Okay, we had a passage we read in Samaria. Okay, the people obviously Samaritans. Okay, this is between Judah and Galilee. You might want to be familiar with this map. There may be a map on our quiz on Friday. There may not be. You just be ready for it. We'll review for it tomorrow. Okay, but we also see this area is populated with a mixed race of who? Jews, basically Jews and Gentiles. Okay, remember back when they were in captivity, the Israelites, okay, they went through a time where they're under captivity, and they brought upon themselves, and they kind of just made intermarried relationships. So we have this mixed group. They were considered basically dirt to the Jews. Okay, they're like, you're not fully, you're worse than the Gentiles because you're like fake. Okay, we don't acknowledge you at all. Okay, and lastly, we talked about how he looked upon, or they were looked upon with disgust and disdain. Again, as I just said, people did not like them at all. And we mentioned with Jaylene and Tori, okay, if someone that maybe she doesn't like or new or different, they hated her. Not that you hate her, okay? Just for illustration, we talked about with the map, showing where it was, the well, maybe what it looked like. But today we are going to start the second part of the lesson, the Lord. Okay, the Lord in the situation and the story. So if you want to open up your Bibles or follow along in John chapter 4. We have a few verses we're going to read today. But John chapter 4. Okay, looks like we have Grace, Jake, Ellie. Sorry, Jake, I did not see that prayer request, but I will pray for that. I'll pray for that today as well. Good to see Christians, both of you. It's always good to see you both online. All right, chapter verse 6, that's where we're starting today. Okay, and it says this. Now Jacob's well was there, okay, which we mentioned and talked about, right? Remember, it said that well had been giving people water since the time of Jacob. Okay, Jesus, therefore, being wearied with his journey, sat thus on the well, and it was about the 6th hour. We mentioned that yesterday. Okay, there cometh a woman of Samaria to draw water. Jesus saith unto her, give me to drink. Pretty common sense, right? You're thirsty, you go to the place of water, whether a fountain, whether it's at your home in the sink, the fridge, a bottle of water. Okay, you're thirsty, you go get something to drink. So he went to the well. Okay, pretty common sense. Okay, his disciples, it says, for his disciples were gone away into the city to buy meat, to buy food for their journey, okay, to buy whatever supplies they needed. Verse 9. Okay, then saith the woman of Samaria unto him, how is it that thou, being a Jew, askest drink of me, of Samaria? For the Jews have no dealings with the Samaritans. And we mentioned this all yesterday, okay? I read the passage, okay? But we see first with the Lord, okay, his humanity. His humanity, okay? Two things with that. First, he grew weary. Okay, we talked about in the 6th hour is probably more 6 p.m. Okay, remember how long of a journey, you guys remember I mentioned it yesterday, would have been from Jerusalem to the Sitar? An estimate of how many hours? It's not in the notes, I just said it verbally. 4. It was 4 hours. Okay, so say the 6th hour, 6 p.m., so he left maybe right after lunch in Jerusalem, maybe ate something, and they traveled maybe probably by foot, maybe by donkey, okay, but it's most likely by foot since there's a large group of men, okay. That would be tiring, okay. It was probably hot, okay, certainly in that region of the world. Okay, so he gets to this place of Sitar, okay, and he's parched, he's thirsty, right? Emma, after basketball or after we run, you're what? Probably 2 things. Feeling like you can't move, and you're thirsty. No, mostly even too tired to drink. Okay, but we see Jesus grew weary. Jesus, as he is God. Okay, the term we learned for that this year is when he's flesh. Incarnate. Okay, incarnate. Jesus made flesh. Okay, he ate, drank just like any normal person. He and smiled. He had feet that got hot. So we see him first, his humanity, he grew weary. Secondly, in his humanity, we see he looked. Okay, the woman comes up, he asks her why. She automatically knew and said, hey, the Jews don't deal with Samaritans, right? We just read it. Okay, so he obviously looked like a Jew. Okay, this Samaritan woman comes up, he asks for a drink, he's like, well, why are you talking to me? We don't really associate. Okay, so we see these 2 things of his humanity. He was tired, so he was human. He had a body. Okay, that gives us perfect example. Okay, explains everything, proves it to us. Okay, second, we see he looked like any other Jew. The woman of Samaria did not look any different than anyone else. Okay, he didn't look like a king. He didn't look super special. He just looked like a Jewish man. Okay, he was an ordinary person. Okay, Isaiah tells us all the way back in the Old Testament, it indicates that there is nothing about his physical appearance that would attract us to him. Again, okay, it's not like we see him and he's like, oh, it's Jesus, he's glowing. We know it's Jesus. He was just a normal person, just like you and me. Okay, obviously a little bit different. Jewish people look a little bit different than some of us in here. Okay, but they knew he was just a normal man by looking at him. Okay, but secondly, again, this is with his humanity. Weighs and proves that he was all man. Because some people that we've talked about, they didn't believe he was actually a real person. They're like, oh, he was here in our presence, but he wasn't really here. Okay, that's a one way that proves he was actually here. But secondly, we see the Lord in his deity, and this part is a little more important. Okay, we're going to read a few verses with this. First, we see he offered eternal life to this woman. Okay, and again, I read this yesterday, but in verse 13 and 14, it says this. Jesus answered and said unto her, whosoever drinketh of this water shall thirst again. Right? He was parched. The woman went to this well to get physical water. Right? Like water. Okay, Emma always has her dew. Or whatever soda for you California people. Okay, I always have my water, sometimes coffee as well. Okay, we have things to drink. Okay, Jesus told her, hey, you will thirst again though. Right? I'll drink this maybe 30 minutes, maybe after teaching or talking, I'll thirst again. I'll need some more water. My throat will get dry. I'll need a drink. Okay, but Jesus goes on in verse 14, but whosoever drinketh the water that I shall give him shall never thirst. But the water that I shall give him shall be in him a well of water springing up into everlasting life. All right, again, remember this is a Samaritan woman. Okay, they had some of the same beliefs as the Jewish people, but they kind of just like didn't really believe in anything. Okay, they're like this lost civilization between all the Jews. They're like, we're our own people. We just kind of live our lives alone. Okay, so we see Jesus saying, hey, you know this water again, it's temporary. But I can give you, again, he's a normal man to her. She doesn't know who he is. She's not from Jerusalem. Maybe she hasn't heard of any of the miracles of this man, Jesus. He said, hey, I can give you water where you'll never thirst again. Okay, so maybe a normal person thinking in her mind, she's like, how in the world would he give me water to like, so I never thirst again? Do I like drink it and I'm just never thirsty again? You know, maybe she's just a normal person thinking about these things. Is this a water that I just drink? How is this even possible? Okay, in her mind, she does not. Do you guys see what I'm saying? Okay, he's talking about something she doesn't understand. Okay, so first, again, we see he offered eternal life. She doesn't quite understand it yet, but he offered it to her. Okay, but let's move along. Second, we see that Jesus in his deity was omniscient. Do you guys know what omniscient means? All-knowing. It is all-knowing. You're close. You're close. It's okay. Okay, omniscient means all-knowing. Okay, Jesus knows everything. Remember, because Jesus is all man, but all God. Okay, he knows everything. He knew all about the woman, and she soon recognized the fact and even told others of his total knowledge of her. We'll see that in verse 16 and 18. So moving right down just a couple verses from where we just read. Jesus saith unto her, go call thy husband, and come hither. The woman answered and said, I have no husband. Jesus said unto her, thou hast well said, I have no husband, for thou hast had 5 husbands, and he whom thou hast is not thy husband, and that saidest thou truly. Okay, again, this is just a woman he met. This woman walks up to this random guy. He really hasn't even said his name yet. He just said, hey, give me some water. Okay, that was his introduction. Okay, then we see this dialogue, and we see it comes to the point. He offers this eternal life. Okay, then he says, hey, he says this question, and she's like, I have no husband. He said, you answered well. Because again, Jesus is all-knowing. He's omniscient. He already knew the truth, but then he goes on to tell her, hey, I'm going to show you something. He didn't say that, obviously. We just read it. But he said, hey, I'm going to show you something. Okay, you're right. You have no husband because you have had 5 husbands, and the man you're with right now isn't even your husband. How would you feel if this random guy just said is like, all right, who are you? Like, why are you stalking me? Why are you following me? How do you know these things about me, right? That'd be maybe a little weird. To this lady, she's like, what in the world is going on? first he's talking about this water that I can drink and I'll never thirst again. Now he knows, like, my background. I've just met this guy. What in the world is going on? Okay, so we see this going through. Okay, so we see, again, Jesus' deity. He's showing it to this woman. Okay, he offered eternal life. Okay, he was omniscient, all-knowing, showing that to her. Okay, thirdly, we see he claims his deity. Okay, so a little bit more happens in the story. In verse 19, the woman saith unto him, Sir, I perceive that thou art a prophet. Okay, our fathers worshipped this mountain, and ye say that in Jerusalem is the place where men ought to worship. Okay, verse 21, Jesus saith unto her, Woman, believe me, the hour cometh when ye shall neither in this mountain, nor yet at Jerusalem worship the Father. Okay, so now he's prophesying. He said, hey, we won't worship in Jerusalem. We won't worship here. Okay, you'll be able to worship the Father anywhere in the future. Okay, God is a spirit. Okay, talking about the Holy Spirit. And they that worship him must worship him in spirit and in truth. Okay, verse 25, this is the highlight of Jesus claiming his deity. Okay, he mentioned that, and the woman says this. The woman saith unto him, I know that Messiah cometh, which is called Christ. When he is come, he will tell us all things. Okay, again, the Samaritans were half Gentiles and half what? Okay, so they knew a little bit about prophecies. Okay, they maybe knew some scripture. Doesn't mean they believed all of it, but they knew it. Remember, they were half Jewish, so they probably have heard it, whether it's from their ancestors, their parents. Okay? They've heard these things. There will be this coming Messiah. And she even says, when this Messiah comes, he will tell us all things. Well, what did Jesus just do? He told her, there's no way he would have known that. Okay, so he's about to tell unto them, okay, I have meat to eat that ye know not of. Okay, the word meat, a lot of times in the Bible, means like a truth. Okay, a lot of times we say, hey, get the meat of the word. Okay, meaning we're getting truth from the word, things we can apply to our lives. Okay, or eat, the Bible tells us in a lot of references to eat. Okay, not just, you're supposed to not just be spoon-fed, but to take and dive into the word, the meat of the Bible. Okay, to learn it yourself, to not be spoon-fed. That's another reference, side note. Okay, but we see Jesus claiming his deity. She says, hey, the Messiah, okay, I've heard of him. He will come. He'll tell us all things. And then he says, I have meat or truth, okay, for you to eat or learn that ye know not of. I have truth that you don't know. And I just told you it. Okay, I told you about this eternal life, and she didn't know what it was. Remember, we just talked about, she didn't know what that meant, this everlasting water. Okay, so we see the last thing in this part, okay, his deity, it was sustained by spiritual food. Okay, moving down to verse 32, which I just read, but he said unto them, I have meat to eat that ye know not of. She continues to say, therefore said, or the disciples come in the story, therefore said the disciples one to another, hath any man brought him aught to eat? Okay, and we're going to move here in a second to what Jesus' response is. Again, where were the disciples at this time when Jesus was at the well? To get food, and it specifically said to go get meat. Okay, a physical meat, right? We like meat. I love steak. It's probably my favorite food. Okay, who likes steak? Meats, chicken, fish, asada, you know what I'm saying? Meats. We love meats. Unless you're a vegetarian, I'm sorry. Ribs, okay, ribs are great too. Okay, we love meat. There's so many meats that I could say. But we love meats, basis of the story. So the disciples went to go get this meat. Okay, they come back. Jesus is talking to this random woman. He says, hey, I'm going to tell you about or give you this meat or this knowledge, this truth, okay, that ye know not of. Now the disciples are thinking a little bit. Remember, they're following Jesus. They see miracles, but they don't understand everything either, right? There's a lot of times, even in the future, Jesus will say something like, Jesus, we don't really understand. We're going to follow you, but we don't understand. Okay, even when Jesus says, hey, I have to die on the cross and this is going to happen, they didn't understand. Like, why? Stay with us. Okay, we'll protect you. We'll help each other. We'll keep on doing good things. Stay with us. Okay, so the disciples are also questioning, hey, what does this mean? We have the meat right here, Jesus. What are you talking about, this meat? Okay, so that's going to take us to our next part of the lesson that we're going to be done with. Okay, just a few things that we're done. Okay, with the Lord, we see his dedication and urgency to do God's will. Okay, so he's in this place. Okay, Jesus, or God, again, brings this lady to him at the well. He's sitting there. She comes. The disciples are grocery shopping, basically. They come back up to meet with Jesus. They see this conversation. Okay, going to chapter 4, verse 34 and 35. Okay, Jesus saith unto them, the disciples and the lady, says, my meat is to do the will of him that sent me, and to finish his work. Say not ye, there are yet 4 months, and then cometh harvest. Behold, I say unto you, lift up your eyes, and look on the fields, for they are white already to harvest. Okay, again, these people might be a little confused, even reading it, right? It's like some wordplay. It's like, man, what is he trying to say? Okay, so we see him dedicating and telling the urgency of why he's on earth. Okay, first he said, I'm here to do what? It says in verse 34, my meat is to do the what? The will of him that's the will of the Father. Okay, he was there to do God's purpose. Okay, which they don't know yet. Okay, but it will be dying on the cross. There are 4 months, and then cometh harvest. Behold, I say unto you, lift up your eyes. Okay, this is referencing to, okay, you say in a few months there will be harvest ready to go get. All right, but what Jesus is telling, hey, there's already a field that is plenteous. Okay, he's no longer talking about crops. Okay, he's talking about his purpose is to seek and to save those that are lost. He's saying, hey, there's all these people, all these souls. Okay, we're in Samaria, this place that is, remember, disgusted upon people, denied about the Jews. He said, hey, again, remember how we talked about this lesson is to talk about how there's no boundaries on salvation. All the disciples are Jews. Okay, they don't really associate with Samaritans. Jesus is saying, hey, the harvest is plenteous. See all these people? See all these Samaritans that don't know the truth? Man, we're here to tell them. Does that make sense? Okay, the disciples, remember Jews, they're like, we don't associate with these people. Jesus, why are you talking to this Samaritan woman? Okay, and he says these things. He's like, hey, I'm here to do the will of my Father. You guys say, hey, wait for the field to be plenty. The thing is, the field is already plenty. It's ready for the harvest. These people right here, they need you. They need you. Okay, so he's telling them, hey, this is my God's will. And the last thing for today, we see his concern for his disciples. So moving along, okay, verse 35 I already read, so verse 36 through 38. Okay, Jesus continues to say, and he that reapeth receiveth wages, and gathereth fruit unto life eternal, that both he that soweth and he that reapeth may rejoice together. And herein is that saying true, one soweth and another reapeth. I sent you to reap that whereon ye bestowed no labor. Other men labored, and ye are entered into their labors. Okay, we see Jesus answering them. He says, and he that reapeth receiveth wages. Okay, Christ longed for his disciples to have his burden for souls. All right, again, they're following Jesus, they're obeying him, they're seeing Jesus perform these miracles, but he wants the disciples to understand, hey, my purpose is going to be to die on the cross. I'm going to tell you one day. It's to do my Father's will. Your purpose, see these people here, see these souls, they're ready. They're ready. Just like this woman he's talking to right now, she was open to this conversation. She's learning. These people are waiting for someone to tell them the truth. Okay, we see that he wants to reward us for witnessing too. The Bible tells us in other passages, says, hey, soul is saved. Okay, when you do God's will, and sometimes he brings them to you, sometimes we have to go out and find them. Okay, God rewards us with crowns up in heaven. The Bible also tells us he's preparing a mansion for us. I'm sure you've heard that before. We receive crowns for doing the will of God. Okay, we might not receive it here on earth. Doing God's will, we might not get gold and mansions here on earth. The thing is, he says it is waiting for you in heaven. Because we do it not for us, but for who? For God. Okay, the Bible tells us for not our will, but thine. but thine, Lord. Okay, we see that later on in the Bible as well. Okay, are you as determined to do his will or God's will as he or Jesus was to do his Father's will? Remember, if we're a Christian, okay, it literally means little Christ. Okay, to be like Christ. Okay, Christ shows us in the story. Okay, a lot of times maybe we don't want to talk to a random person, right? I'm right in there. I don't like talking to people. I really don't. You can go ask Mrs. Coral. Like, people invite me over to their house, and I'm like, no, I'd rather stay home, or let's go see your family. I don't want to hang out with people. Okay, certainly if it's a stranger, like if I'm at the gym, I'm like, everyone stay away from me. I'm doing my thing. Get out of here, right? But we see Jesus show us a perfect example. Commonplace. This lady comes, and does he just ignore her and get some water and leave? No. He creates a conversation. This before he creates this maybe uncomfortable conversation, certainly for her, okay, and tells her the truth of God's will. And then the disciples come, and he tells them his purpose, his goal. Okay, and us, if you're a Christian or as Christians, our job, okay, does that mean the only thing we do in life is that? No. Okay, but that means we have to be the term is soul conscious. Whether it's a coworker, a family member, a friend, okay, a sibling, a parent. Okay, if we're saved, the Bible tells us to go out, and Jesus commanded us to go out and to tell the world. To be soul conscious. Okay, to have that purpose. Remember, Jesus said, I'm here to do whose will? God's will, or my Father's will. To tell the truth to people. Okay, and we need to have that same purpose in our heart. Even if it's, hey, I'm going to a grocery store, a thing called a gospel tract. Our church has lots of them. You can grab them. You can ask the front office for one. You can say, hey, I'd like to give this to you. It's good news. That's still doing your part. You don't have to go and talk to them for a long time, but you're telling them the truth. All right, I challenge you. Okay, try to do it once a week. Whether it's a coworker, a friend, a family member that you maybe know that doesn't know the truth, okay, tell them about the truth. Say, hey, man, God loves you. He loved you so much, he sent his son to die for you. Okay, you can be saved. All right? I challenge you to do that. If you have any questions on that, you can ask. That is it for the lesson today. Tomorrow we'll have our conclusion. Okay, we also will have our verse quiz over chapter 4, verse 13 and 14. Okay, those verses, you should know them, but it says this, Jesus said, of this water shall thirst again. But whosoever drinketh of the water that I shall give him shall never thirst. But the water that I shall give him shall be in him a what? A well of water springing up into everlasting life. All right, those are our verses for tomorrow. Be ready for that. You guys should have been able to finish those booklets. I'm pretty sure most of you guys, if not all of you, have shown that to me in the class. Distant learners, make sure you're showing me or sending me pictures of your booklet. It's only like 5 questions this time, so it should have been real easy. Okay, those verses. There is no homework today. It is Wednesday. I said there was homework earlier on accident. I'm sorry. Okay, it is Wednesday. There is no homework, but make sure you're ready for that verse quiz. Make sure that booklet's done. We'll finish the conclusion of the lesson tomorrow. If you have any questions, let me know. We'll see you next hour. right there. You guys turn in your homework. If you did not, no one should have turned it in, actually. We're turning in our homework now. Make sure you throw your name back in the chat so I know you're here. You guys were all here last hour, so good. The homework needs to be turned in. If you don't want to turn it in by picture, you can turn everything in by paper. I think that's what Christian Halsey does sometimes. Okay, make sure you turn everything in. If it's not turned in by picture today or by paper on Friday, it is a 0. So make sure you're on top of that, turning everything in. Okay, we left off at extradition, talking about those the 3 things with the divided powers. Okay, we talked about those 3 things yesterday. We're going to pick up right where we left off. Did the TV turn off? Sorry, good to see Ellie, Grace, Jake. Make sure both Christians, you guys are back in the chat. Make sure you didn't fall back asleep or anything. All right, everyone has their notes out. Everything put away so I don't have to take it away. Awesome. Today we are going to be talking about the history of federalism. Okay, that's kind of what this chapter is over, American federalism. Okay, and the rise of central power. Okay, the first term we need to know, and it ruled for about a little less than 40 years, about 30 years, okay, is dual federalism. Okay, dual federalism. This is where the founders desire that the powers of the national government be exercised independently of the states and vice versa. Each government is independent to exercise their power without the assistance of other governments. Okay, most early Americans believed that while it is necessary for the individual governments to cooperate with each other, they should not combine their governmental powers in order to accomplish any purpose. Okay, that's what brought along dual federalism. Thank you, Christian. It's just a joke. He said, I promise I'm not asleep. Okay, but during this early part of this century, okay, states believed that they could escape or succeed from the Union in this idea of dual federalism. Okay, many also believed that they could ignore a law if they deemed it unconstitutional. This belief became known as the doctrine of nullification. Was everyone finished with the last one? Okay, the doctrine of nullification. Okay, is the belief that the state could nullify or dismiss laws and even succeed or surpass if it considered a law passed by Congress is to be unconstitutional. This was made because its adherents believed they could nullify these laws, again, if they were unconstitutional, if they weren't based off the Constitution. This conflict, okay, we see a conflict with these 2 different things between the states and the federal government, okay, with trying to have the same powers, okay. We see the dual federalism being a factor. People that didn't like it, you have this doctrine of nullification, and this is going to bring us to a bit of a civil war. Okay, the conflict between the states and the federal government culminated in the Civil War. Those advocating states' rights lost the war, and the national government exercised the power to keep the Union together. Okay, one of the main arguments or court cases after this time in dealing with these things that we need to know is Gibbons versus Ogden. Gibbons versus Ogden. Okay, this is a little bit after the Civil War. It happened in the New York, New Jersey area. Okay, this case is in which John Marshall, I don't think that's supposed to say rude. It's supposed to be ruled. I'm sorry. Give me a second. Okay, it's where John Marshall ruled that commerce does not only include the transportation of goods, but also the means of transportation, giving the Congress to more power to regulate commerce or business. The Marshall Court broadly defined commerce to include not only transportation of these goods, but the means of them. This decision and other Supreme Court cases gave even broader interpretations to the power of Congress to regulate commerce. Okay, although the federal government had won an upper hand over the states, okay, the system of dual federalism that the founders created remained intact. The state and the national government were still separate. Each had its own responsibilities to fulfill. Throughout the 19th century and into the early 20th century, there was a strong effort to maintain this distinction, okay, even up to our time today. Okay, this is going to bring us to a new type. So we have dual federalism. Okay, we had that to the early 20th century, so 1913 is where it ended. Okay, but that's going to bring us to a different type of federalism, okay, called cooperative federalism, okay. As this 20th century progressed, so around 1913, right after that, 1914 time, okay, we see this cooperative federalism. The rise of national government to prominence above the states was made possible in part by the institution of federal income tax. In 1913, the 16th Amendment provided for the federal government to tax personal incomes. Prior to 1913, the Constitution forbade Congress to place a direct tax on people. Wouldn't that have been nice? I said, wouldn't that have been nice? To not have to be directly taxed. But it's just something we have now. You guys work. You guys don't claim independent yet, I'm sure. Neither of you are 18 yet, right? I was say your birthday is soon, right? Even when you claim independent, though, a lot of times, like if you're still living at home or something, your parents can still do it through theirs, but you have to make sure you claim everything. Oh, for your paychecks?
Yes. It's so sad.
Yeah, California is.
So much money, and then I look all the way at the bottom.
Noah, you did you go to? No, Jake did. Never mind. I thought it was you. It's Jake. He went to Gorman for a little bit. You guys know what that is? It's kind of like it's not public school. What are they called? Charter school. It's a charter school, and I worked there in college. It was like a job I did during college, and it like paid really good for like just me doing a basic job. I got paid like 18 or 19 bucks an hour, but like yeah, taxes because it's a school were very, very high.
I swear, I want to like cry. I'm like, how
It was sad. It was like minus $250. It's like.
the highest one was like 700, and then I looked all the way at the bottom, and it dropped out to like 525.
Yep, California taxes, gotta love them.
Like, come on, dude.
It's okay though. Even though more taxes get taken out, your tax return at the beginning of the year, once you claim independent, you get a lot back if you do it right. Okay, so like every time I have a job, even in Michigan or anywhere, they give you an option when you're doing your forms and stuff, take out as much as you can. So like when they say, hey, how much would you want to be taken out of each check through the taxes, you say as much as can, because then you'll get more in return when tax return comes. That's what I've always done. Because sometimes if you don't do it right, when it comes to tax return, where a lot of people get money back from their taxes, you didn't pay enough, so you have to pay more actually. I have a few friends that had that. You had to pay like $400. Oh yeah, they're making bank. All right, sorry I got sidetracked a little bit. Moving along. All right, with this we're going to see some hardships give rise with this cooperative federalism. Okay, which is going to bring us. Okay, so around, you guys know what's happening around 1913. Yes, World War I is going to start very shortly. You know what happened during the World Wars with commerce though, with business though. What happened? Something everyone knows. The Great Depression. Thank you. Some of us are listening. The Great Depression and World War I provided the federal government with the opportunity to extend its taxing power in the name of aiding the states by instituting a system of cooperative federalism. Okay, this World War I and Great Depression, okay, allowed the states to do this tax system, okay, in aid of the war. Okay, they say, hey, we need everyone to do their part, pay to us so we can do war. Okay, because war is expensive. Okay, so we see this time. So know that the Great Depression and World War I were those starts to it, to the cooperative federalism. Everyone good on this one? Okay, gradually, the Congress began to see that it could use the revenues from tax money to influence the states, which we even see today. Okay, so through this time when they started this cooperative federalism, we see this control of power. Again, this is going to go on, this type of federalism, until around 1960s, and then it's going to change to something else. Okay, so this will bring us to a thing, okay, after World War II, so just a few years later, the flow of federal money to the states not only continued, but it increased, beginning with the construction of the federal interstate highway system in the 1950s. States began to accept large amounts of money called grants. Grants, which are large amounts of money given with special conditions and restrictions. That's from, sorry, not form. Let me fix it real quick. I'm sorry, it bothers me. Okay, from the federal government to state governments. Okay, grants would be these portions of money. I'm sure we already know what those are. Okay, they would come from Washington in order to improve their roads. However, as the state government soon discovered, with these grants came special conditions and restrictions. Okay, so even today, there's a lot of grants. Okay, but there are a lot of restrictions on it, so not everyone can get these grants. Okay, so that's a basic grant, a large amount of money, okay, that states begin to accept. Okay, but more specifically, a federal grant. Our next note, a federal grant are monies the national government gives to state or local governments for some designated purpose. Okay, although federal grants today consist of money, the first modern grants consisted of land. Okay, so these original these type of grants did not really pertain of exact money towards something, funding something, but it was kind of like land or a building or an area towards something. This would happen first with Morrill Land Grant Act in 1862. Okay, this grant apportioned to each state a quantity equal to 30,000 acres of land for each of its senators and representatives in Congress. Okay, some of those land grant colleges still operate today, including Purdue, Texas A&M, and Michigan State University. The first large grant of money from the federal government to the states took place under the New Deal, the legislative plan from President Franklin D. Roosevelt. Okay, so these federal grants given money, remember they started out as land, but given money to specific things, just like the picture I have there, okay, just like medical or anything like that. Okay, but this will bring us to our last type of federalism, okay, which is already up to our date today. Okay, it might be a little bit different than how it started, but it is what we use today. We have coercive federalism. Okay, it started around the mid-1960s up to today. Again, it might be a little bit different than how it started, but it is a system in which Congress issues more penalties than incentives to force the states to implement federal programs. Okay, President Richard Nixon used the expression new federalism, okay, to describe an effort to return more decision-making power to the states. Yes, ma'am. Yes. Okay, so we see Richard Nixon calling it a new federalism. Okay, but not until Ronald Reagan, who began to move federal and state relations in different directions. A president, Reagan cut grant programs, thereby seeking to cut federal spending and reduce Washington's role in domestic and state affairs. By doing so, he made the states less dependent on the federal government for their support. Okay, Reagan and the Congress also set up new block grants and reduced the funds going to local governments. Unfortunately, the move toward new federalism was short-lived. Under Reagan's successors, federal dominance over the states continues to grow. Okay, so we see a few notes that didn't go through, sorry. Okay, we have new federalism. This was under Nixon, the effort to return more decision-making power to the states rather than the federal government. Because during that time of the Great Depression and everything, it became more of the federal government rather than the states. Sorry, forgot to press the clicker. But some of these grants we've been talking about and everything. Okay, as I just said, Ronald Reagan cut these grant programs, seeking to cut federal spending and reduce Washington's role in domestic and state affairs. Okay, which is our next note. Okay, this will bring us to federalism today. Today, the states labor under the mandates of the national government with little funding to pay for it. The slow erosion of state authority has come about and continues mostly as a result of the relationship between Supreme Court and Congress. Since the 1930s, both institutions have allowed each other to exercise control over the states to unprecedented extents. Congress has refused to use its constitutional authority to check the power of the judiciary, and the court has failed to rightly judge the constitutionality of legislation by Congress. Okay, as a result, the federal government has acquired a stronghold over the states through the Supreme Court and Congress. Okay, which is then bring us to our next amendment and this relationship between the states and the Supreme Court. Okay, the 14th Amendment and due process were one of the ways that the Supreme Court has coerced the states into submission. Okay, we also have these things called court orders. Court orders, which are commonly issued regarding state prisons, education, civil rights, and voting and elections. Okay, this was from a result. States today must comply with the Bill of Rights that was originally intended to protect the people and states from the federal government. Okay, these court orders, the Supreme Court has also developed a habit of ordering states into action. In the past, it was not unusual for the Supreme Court to declare a state law unconstitutional, but the court rarely told the states what they must do. Okay, there's a few cases with this, but the one we're going to talk about, okay, with this relationship between the states, we have the states and the Supreme Court with these court orders, and then we have this relationship between the states and the Congress. Basically, it's just the relationship between states and federal government. Okay, but one important case that comes to mind is Garcia versus the San Antonio Metropolitan Authority. Okay, this ruled that Congress could make state governments comply with the same minimum wage and maximum hour legislation as was required for federal employees. Okay, this started since the New Deal. Congress had been highly successful in its efforts to control the states. Okay, so the court case that gave Congress almost unlimited reign was this one, Garcia versus San Antonio Metropolitan Authority. Okay, today there does not seem to be any true limit on the power of Congress. Even with the unenumerated powers of Article 1 and the 10th Amendment, Justice Sandra O'Connor issue of federalism is whether any area remains in which a state may act free of federal interference. Congress has increased the power of federal government over the states through preemptions and federal grants. Okay, so we see federal government taking a lot of power even today. Okay, so that's going to bring us to what is this term, as I just said it, preemptions. Preemptions. That is when a federal law supersedes or overrides a similar state law. Okay, it's when a federal law supersedes or overrides a similar state law. Preemptions have proliferated since the 1950s. Today, they are found mostly in the laws regarding the environment, health, and safety. A good example of early preemption is found in the enforcement of the Water Quality Act of 1965. Okay, this law was the first statute to establish a national policy on pollution control. Congress informed the states that they must establish water regulations that would be acceptable to the United States government. If they failed to do so, national guidelines would be established for the states to implement. Should the states refuse to enforce the national policy, the federal government would seize the jurisdiction of water regulation from the states. Again, we see the federal government taking the power from who? From the states or the people. Okay, Washington has used this approach in several other areas, one of the most famous being the regulation of workers' health and safety through the Occupational Safety and Health Administration, or the OSHA. Okay, so we see again this back and forth between state power, people power, and federal government power. It's supposed to be balanced, okay, but because both have some power, they pull back and forth. Okay, but this is going to bring us, we had federal grants, but another way Congress checks the authority of the states is through the federal grant program. States may receive several types of grants. Okay, we're going to be going over a few different grants, but the first one is block grants. Block grants. They're general purpose, or they were general purpose grants that allow the state to have more jurisdiction in how to use federal funds. Rather than being forced to use the federal funds for what the federal government wanted, the states would say, hey, we want to use it on what we think needs the most funds. Okay, our next one is categorical grants. These are grants that are for a more specific purpose. They give Congress more control over the states. Okay, so say like, hey, here's money for redoing the roads, or I don't know, here's money for this specific building, this specific thing. Categorical grants. Categorical grants give Congress more control over states. In both categorical and block grants, money granted to states is accompanied by rules that govern the use of that money. These rules are called mandates or conditions of aid. They're called mandates or conditions of aid. These are rules that govern the use of money granted to the states. Mandates or conditions of aid. They're rules that govern the use of money granted to the states. The states began to lose their independence when they began accepting large amounts of funding from Washington, D.C. As the mandates increased and the amount of funding for the states did not, many found it hard to pay for all the mandates that the Congress required. States had begun to balk at this ill treatment, saying that if Congress wants a program implemented, it will also have to help defer the cost of the program. One recent example of this controversial case regarding unfunding mandates was, it's not quite recent, I don't think anymore, but 1993, before even I was born, okay, the Motor Voter Law. The Motor Voter Law. Okay, the Motor Voter Law. This required that voting registration be available everywhere. There was a State Department of Motor Vehicles. States believed that if Congress wanted the law implemented, then Congress should pay for it. The Supreme Court ruled in favor of Congress, again giving power to the federal government. Okay, just a few more notes and then we are done. I told you this is a very short chapter. Okay, we will probably have a quiz either tomorrow, or we'll start our next chapter tomorrow and we'll have a quiz on Friday. Okay, Congress, sorry, I'll go back. Looks like some people are still writing. Everyone good? Congress has inundated the states with regulations. Between 1968 to 1978, Congress passed more regulatory laws than in its previous 179 years. So just in a 10-year span, from the late 60s to the late 70s, okay, it passed more laws or regulatory laws than its previous 179 years. Okay, there are just two more notes. Okay, Unfunded Mandates Reform Act, which happened in 1995, so shortly after the motor voter laws, okay, states that Congress would have to conduct studies to determine the cost of mandates on the states. And there's one more note. Give me 1 second. Am I good with this one? Okay, and the last note, one of the main cases that deals with this, or in this regarding to all these mandates and the relationship between the states and the federal government, we have the United States versus Lopez. Okay, Congress states in the court case of this case which banned Congress from policing local school zones, was the first federal case in 60 years to uphold the delegated powers as intended by the founders. Chief Justice, I can't really say his name, it's like Rehnquist, okay, or Rehnquist, okay, even quoted James Madison in Federalist number 45 when he said, okay, the powers delegated by the proposed constitution of the federal government are few and defined. Those which are to remain in the state government are numerous and indefinite. More important than any decision by our government, however, is the decision that each citizen makes to be a good steward of the form of government that God has given him. Part of this responsibility is just knowing how that government operates. Okay, again, this man, and with this case, the judge said, hey, James Madison, one of our founders, even said this, okay, it should not be dealt by the federal government, but by the state and the people. Okay, but the people do have to follow with everything for everything to work. Okay, that is the end of the chapter. Okay, there is no homework because it is Wednesday. Okay, I will give you guys the option. Okay, distant learners, you can say it as well. We can either take our quiz and review quickly right now and take it tomorrow, or we can review tomorrow and take it on Friday. Your guys' choice. Who would like to take the quiz tomorrow? Who would like to take it Friday? All right, not everyone voted, but it looked like more people wanted Friday. We'll take that quiz Friday. We'll review tomorrow. It will be over chapter 10. It's a short chapter, but we'll review for it so you should know most of the things that are on it. If you guys have any questions, let me know, but there is no homework. Distant learners, hope you have a great day. We will see you tomorrow.
All right, welcome to chemistry. We're going to get started this morning. Go ahead and get out your textbooks and supplements. We are on page 82 of the textbook, page 94 of the supplement. Page 82 of the textbook, page 94 of the supplement. We left off yesterday introducing the idea of a calorimeter, which is just a device for measuring heat flow. What are the odds I actually have styrofoam cups here? I'm thinking like 0. Because I need it, so like it's not going to be here. Let's see here. I completely forgot to look for these yesterday. My defense, I was grading. All right. I do not. All right, well, I have plastic cups so you guys can at least get the idea of what we could do. What are you going to do? Okay, anyway, styrofoam is a natural insulator. A vacuum is a better insulator. So if you put a styrofoam cup inside another cup, I'm fully aware these are plastic. Okay, this wouldn't work. But if you put a styrofoam cup in another cup, you've created a vacuum with insulators on both sides. So you can, and then cardboard lid, boom, calorimeter. Okay, thermometer in the top. Real easy. If I had styrofoam cups, I would actually demonstrate it, but we'll come back to that later. I'll revisit that. Oh, goodness. I don't want to promise anything, but soon. Yes? Yeah, there's a vacuum seal. Basically, think overbuilt thermos, and you're about there. Because that's how thermoses keep your water cold. Like this. Okay? There's a vacuum between the inner cylinder and the outer cylinder. If you notice, there's a little bit of a gap when one breaks or one falls apart. If you look inside, there's a gap there because it was originally a vacuum. That's why they're so heavy, because the steel has to be kind of thick for that to work without it imploding. Yeah, that's also a calorimeter. I mean, if you stick a thermometer in it, boom, done. But I'm not going to mix chemicals in that because I want to drink that. All right, anyway, so I'll come back to that later at some point. Yeah, real lab ones are. We're talking about for demonstrations or for like quick enough, you know. Yeah, we're talking stuff that like, it's fine, you know, not like. Okay, we're moving on. Anyway, so it doesn't have to be super overbuilt thing. It's nice if it is, but it doesn't have to be. Yeah. That's just a nickname because it kind of looks like a bomb. It's not actually a bomb. That's just kind of its shape. Yeah, I'm sure you could. Okay, we're moving on. All right, so, goodness, this devolved quickly. Let me see here. The difference between the constant pressure calorimeter and the bomb calorimeter is the bomb calorimeter, you can keep a constant pressure if you're in the pressure fluctuating area. And you can let the pressure vary instead, or no, I'm sorry, you can let the pressure vary instead of the volume varying. So it's useful when studying gases and things like that. Huh? For the bomb calorimeter, yeah. The constant pressure is just kind of a rubber top. So that rubber insulator on the top means that it's technically getting the same pressure as the atmosphere. So the other one is more sealed. That's over my head. Not my job. All right. Yeah, above my pay grade. Yeah, that's an understatement. All right, anyway. Let me see here. Heat exchange in the process under study results in a temperature change of the water in the calorimeter. Okay, just going to debunk this myth right now. Thermometers do not measure heat. They measure kinetic energy, which we often interpret as the heat we will feel when that energy is transferred or removed from us. Huh? Yeah, we measure temperature, but that's kinetic energy. So temperature is kinetic energy, not heat. Okay? So it's improper to say 3 degrees Celsius of heat was gained or lost. That's incorrect, because it's not measuring heat. It's measuring kinetic energy of molecules. All right, let me see here. Realistically speaking, heat does either enter or leave the container during the reaction. The better built the calorimeter, the more you can minimize that, but it's going to happen. For our calculations in here, we're going to assume that we're in a perfect world and that no heat leaves. Okay, we're going to assume we have a perfectly insulated calorimeter. Yes, it's a big assumption. Deal with it. Okay? Because unless you want to make the math way harder than it needs to be. No. All right. You can look it up. All right. So I am on there we go. So we do use two formulas, specifically 6.8, where the heat lost plus the heat gained must equal 0. In other words, whatever the system loses, the surroundings gain, so it has to zero out. Whatever the surroundings lose, the system has to gain, so it zeroes out. So what we can do then is set up negative MC delta T lost is equal to positive MC delta T gained, okay? Because we're just substituting in for Q. Okay, so if we subtract gained from both sides and substitute, that's how we get from 6.8 to 6.9. Equation 6.9 is what we'll use the most. And you might be wondering to yourself, when might I ever use this? And y'all are like, Mr. S, we didn't actually ask. Too bad. Example 6.3. In an experiment to find the specific heat of lead, 49.8 grams of lead at 100 degrees Celsius was placed in a coffee cup calorimeter containing 75 grams of H2O at 21 degrees Celsius. The final temperature of the mixture was 22.7 degrees Celsius. What is the specific heat of lead? And we're assuming that no heat is lost to the calorimeter or the surroundings because we're going to ignore physics to study chemistry. All right, so what are you going to do? All right, so first of all, I'm going to grab the brand new equation we just have. I'm looking at lead. Lead is going to lose heat in this example, right? Yes, lead is losing heat in this example. So lead is going to be on the left because it's the one losing heat. Water is on the right because it's what's gaining heat. Does that make sense? You have to read the problem and figure out which is which. Okay, now that subscript, the only reason for the parentheses in this is so that subscript goes to every single term. Okay, so we don't have to worry about it and the negative. But anyway, we're looking for the specific heat of lead. That's in the first line of the problem. So we need to get C sub PB on its own. So we're going to divide both sides by M delta T. And I think we're going to take care of the negative there. Yep, there we go. Okay, so all we're doing here is basic algebra. We just divided both sides by the same thing to get C by itself. Okay, notice that I just put PB by C because that subscript goes to every term in the parentheses. All right, and then at this point, I look up a bunch of stuff in tables and look at my problem and plug stuff in. Okay, mass of water is going to be 75 grams because that's what we're told in the problem. The specific heat of water is 4.18 joules per gram degree Celsius. That's one you should probably memorize because it's going to come up a lot. Okay, like I'm not telling you guys you have to memorize it, but you probably will by the end of the chapter. Okay. And then delta T is 22.7 minus 21 degrees Celsius because the water has a final temperature of 22.7 and an initial temperature of 21 degrees Celsius. Notice how little the water changes despite us putting a 100 degrees Celsius item in there. Okay, water specific heat is high. Okay, just is. All right, so there's reason for that. So anyway, then on the bottom, we have negative 49.8 grams. I can read, I promise. 49.8 grams times its difference in temperature, which is, well, significantly greater by a lot. It started at 100 degrees Celsius, now it's 22.7. Because what you do is you add stuff in a calorimeter, you stir, and you stir until the temperature is constant, like it stops changing. Okay, and then everything's temperature inside is the same temperature. That's the final temperature for both things. Okay, so that's what we're doing here. All right, and then we have fun trying to keep track of parentheses in our calculator, and we get 0.138 joules per gram degree Celsius. Okay, the specific heat of lead, not much. Not much at all, actually. Answer. Because water, when it's a liquid, does weird things. We talked about it briefly, but specifically water as a liquid does hydrogen bonding. And ice it does, but not to the same extent. Water does not want to change. That's why it has such a wide range of being liquid. It's actually it's got a really wide range of being liquid. Most things are solid or gas at room temp. Water is one of the few liquids. And then most liquids at room temp can be quickly made to be one or the other. with the exception of a lot of oils. Oils are also pretty resilient there. Different reasons though. But water is just, the way water behaves on its own is absolutely necessary for life to work. It also makes it a really weird chemical. So that's why. When it's ice, because of the solid crystal structure, nothing's moving, the heat can go through faster. That's the short answer. Nope, wrong side. All right. Now, in section 4.3, you learned how to balance chemical equations, how balanced chemical equations can be used to calculate amounts of products or reactants involved in a specific situation. We may also use balance equations to determine the amount of heat liberated or absorbed in a chemical reaction between various amounts of reactants. Okay, so if we're given a chemical equation, if we're given all the pieces, we can figure out exactly how much heat is gained or lost by a system. The total amount of heat liberated or absorbed between the start of a reaction and its end, where all the products are at the original temperature of the reactants, is the heat of reaction. Okay? If pressure is constant, then the heat of reaction equals enthalpy change, delta H. Okay? So we will often represent this as delta H as long as P is constant. Very realistically, in your everyday life, P is constant in any scenario like that. If you're in a lab, the atmospheric pressure in that lab is not going to change between the start and the end of that reaction most of the time. Okay? If you're in a situation like that, you've already done a lot more math, you've taken a lot more chemistry classes, and you already kind of know how to handle it. Okay? But for our everyday in here, that's fine. What? Yeah, or if not, well, actually, yeah, some do. And then sometimes there's like very random things where like you might be doing something, like there have been experiments on a rocket on its way to space and pressure changes wildly on that trip. So at that point you have to calculate that in, which is actually very useful if you're, say, I don't know, having rocket fuel. It's very useful to know that. Anyway, so just throwing that out there. It's very important to account for that when you're doing things like that, but honestly, at this level, we're okay just assuming pressure's constant, oversimplify. Okay, so that's what we're going to do. When we account for this, we use what we call a thermochemical equation. Okay, you guys are used to chemical equations. Thermo just means we're going to add temperature in. Okay, no, correction. We're going to add heat transfer in. It's not temperature. They're different. Yep, I know. It's one of those things that's hard to get out of your brain because in everyday speak, temperature is heat. Not in this class. All right, so it doesn't mean I'm immune from the way English works. All right, so let's consider an exothermic reaction. Okay, first of all, let's just look at the combination of hydrogen and oxygen to make water. Sorry, it's not quite as exciting as you were hoping. All right, so we have hydrogen and water. When they react, we get two waters, but this is the part we normally leave off, plus heat in the form of 572 kilojoules of energy. Okay. Let me see here. Now, in this case, the coefficients are taken to mean mole amounts. This is not a single molecule releases 572 kilojoules. That would be a lot, and that would be a problem real fast. Okay? This is per mole, which remember is how much of something? Yeah, an Avogadro's number, 6.022 times 10 to the 23rd. Okay, so it takes that many molecules. Well, actually it takes double that for hydrogen. But anyway, because 2 moles. Anyway, so when you form 2 moles of water, you get this much heat. Now, this is one way we can represent it. Another way we can represent it is by off to the side, not actually writing it as a product, is saying that the delta H is negative because it's releasing heat. It's a product. Okay? So because it's releasing heat, it becomes negative 572 kilojoules. And then another way we could write it is if we want to know how much is in 1 mole, or how much is released for English. If we want to know how much is released in 1 mole of, what I'm trying to say? Okay, if we're only forming 1 mole of the stuff, we can use fractional coefficients and figure out the delta H of that. That's what I'm trying to say, but my brain just froze. Okay, Mr. S.exe has stopped working. All right, so that's what happened there. But anyway, you notice we changed that coefficient to have a half an oxygen. That's not actually how any of this works, but since we're talking about moles and not molecules, we can do that. Okay. Now, just for contrast, okay, I think we come back and refer to it later. But anyway, in contrast, if we look at an endothermic reaction, okay, this is where it's going to absorb heat. So we would write it like this, where it's positive delta H, or we would add the 33.8 kilojoules on the left side. The word heat isn't often needed. You just need to add the energy in there, okay? So we can write it like that if needed. So that's how it would look if we were adding heat in as a reactant versus getting it out as a product. Okay, does that make sense? And you can think of it as a reactant or a product because that's what's happening. Okay, in the first one, heat is being produced, and the second one is being used in the reaction. Okay, so that's what's happening. Yeah. Say that again. You don't directly. That's where that Q is equal to MC delta T comes in. All right, now, standard state. Real quick, throwing this out there. Okay, this is the term we're going to use. We've talked about standard temperature and pressure. This is not that. Okay, even though we're dealing with a pressure and a temperature. Okay, so make sure you're paying attention. In gases, standard temperature and pressure is 1 atmosphere, 273 Kelvin. Notice that's not what we have here. Okay, so standard state is something in its uncombined free element state. Unless I'm mistaken, for diatomic elements, they consider it in its diatomic form. I could be wrong about that. I need to double check. Let's see here. All right, I'm going to have to look at that, but I'm pretty sure that's what's going on. Okay. So what this is this is just our reference point. We have to have somewhere that we call 0, and there's no natural place for it to be 0, except for this is the most natural, if you want to consider it that way. But it's kind of like when we talk about sea level, okay, like the ocean is actually at different levels around the world, but we know sea level is kind of our baseline, okay? And so you're so many feet above sea level. Okay, we talk about that elevation. That's because we just named that our 0 point. If we went from 0 from the lowest point on the Earth's crust, we'd have to count for like the deepest valley in the ocean. That could get obnoxious real quick. So we pick a sea level, and sea level also varies based on region. Yeah, I know, our 0 moves. Don't get me started on this one. Our 0 moves for elevation, because sea level is not always in the same place, because the Earth is not exactly a sphere. It's an oval. It's an oblong thing. It's like an egg. Yeah, we're not getting into that. Okay, anyway. So because life is messy, sea level has to vary where it is based on region. Okay. That goes way beyond what I'm talking about here, but the ideal concept of there being a 0, anything above it is positive, anything below it is negative. Okay. That's what we're talking about here. This is our 0. Okay, so the standard state is the reference point for enthalpies, is the enthalpy of the uncombined or free element in its normal physical state at 1 atmosphere and 298 Kelvin. That may seem random, but that's about 25 degrees Celsius, right? Yes, that's about 25 degrees Celsius, which is right about room temp. Okay, 25 degrees. I don't want to do the conversion. Let me see here. Hey Siri. What's 25 degrees Celsius in Fahrenheit?
25 degrees Celsius is 77 degrees Fahrenheit.
There you go. 77 degrees, so it's slightly above normal room temp, but at a temperature that a lab could be expected to be at pretty easily if needed. Okay, so it allows things to work really well. We note this by adding a degree symbol to the heat of reaction. Okay, I know we're adding a degree symbol to something that's not temperature, just it is what it is, okay? So that's just saying, hey, we declared 0 to be the free state, okay? So if you have just a hydrogen molecule, if you have just an atom of lead, okay, that's 0. So if you have any uncombined element, its enthalpy is 0. It's not on a table. You're supposed to know that. Okay? Make sense? So again, kind of like sea level, it's just our baseline. The standard enthalpy of, whoops, hold on. All right, so main takeaway here is any element in the standard state has an assigned enthalpy of 0, where it looks like that. That's kind of the whole point of standard state. Standard enthalpy of formation, where we add a subscript F. Yes, the symbol gets very complicated very quickly. Not my fault. All right, the enthalpy changes in which 1 mole of a compound is formed from its elements in their standard states. This has been calculated by experimentation, much like we just did in the previous example with that sample of lead. Okay, this gets calculated repeatedly in labs, and the average is now on a table for everyone to look up. That table is on page 84 of your textbook. You might want to jot that down in your supplement because I was not about to copy that table. All right, page 84 of your textbook. And that delta H, or standard enthalpy of formation, is actually easier to say than the symbol, is where we formed 1 mole of it. So if you look at water as a liquid, you see it's negative 285.8. Which you'll notice is scarily similar to that 286 kilojoules in equation 12. Just throwing that out there. With difference in rounding. That's it. That's all it is. Okay? So that's how they get it. We form 1 mole, and that's why the fractional coefficients are useful. If you look at nitrogen oxide, the example I gave in 613 and 614, you'll notice that is also very similar as well, with 33.8 kilojoules. All right, according to the law of conservation of energy, the enthalpy of the products must equal the sum of the enthalpy of the reactants and the change in enthalpy of formation. So this is how your book presents it. I would like you to go ahead and, yes. I'm going to go ahead and correct this here, okay? Because the way this is shown makes it a little harder to know what it is you're supposed to do. And honestly, it never occurred to me until we watched that crash course video, and their equation was a lot more mathematically correct. Let's put it that way, to what you're actually doing. So you might want to jot down under equation 615 this equation, okay? The delta H of a reaction, okay, the whole reaction here, is if I take the sum, goodness, that was horrible. I'm going to just redo that. You all never saw that. That was horrible. This is the Greek letter sigma. The Greek letter sigma in mathematics, I tried, means the sum of. Means you're going to take everything that qualifies as what we're talking about and add it together. Okay, that's what sum means. I mean, I know you guys know what sum means, but that's what the symbol means. Okay, you take whatever qualifies in what I'm about to tell you, and then you're going to add all that together. It's the sum of the number of moles of each product times the change of enthalpy in formation of each product. Okay, so that's what that first bit should say. Okay, it's just, again, this was written by a science teacher, not a math teacher. And that's fine. I mean, they're not wrong in the math. It's just this is what they're actually doing. They just don't have it in the formula, and I don't know, that bugs me. All right, so minus the sum of the number of moles of each reactant times the formation enthalpy of each reactant. Okay, and I'm going to show you guys how we're going to apply this here in just a minute, but that's really what we're doing. Okay, I've never liked this formula in years past, because it doesn't really represent what we were doing in the math. And now I realize why, because that should be our notation. Okay, so I've taught this a few times now, or this chapter a few times now, well, I've taught this class a few times. Well, moving on. I've taught this a few times now, and every time I'm going, man, there's got to be a better way to write that. Yeah, that's how we should write it. Okay, so you want to jot that down as a side note, but that's what we're going to do. We need all the reactants, all the products. All right, everyone have that? Cool, let's go to example Maybe. Cool. Example 6.4, we're calculating the enthalpy change for the combustion of ethanol, which is used to power the V2 and Redstone rockets. Okay, we're actually doing rocket science now. All right, so this is the reaction we're given. We're supposed to figure out, is this going to be an exothermic reaction? Is it going to put off heat? Or is it an endothermic reaction? Do we need to supply it with heat? Okay, and there we go. Here's what we're going to do. So we know that the delta H is going to equal the sum of, and this sigma is going to get butchered over time. That's just going to happen. The number of moles of each product times the change in, the enthalpy of formation of each product. Why does undo not work in this program? I hate that so much. Minus the sum of the number of moles of each reactant times the enthalpy of formation of each reactant. Okay? So basically then what's going to happen is delta H is going to be this big sum minus this other big sum. Okay? And so let's look at the products first. Products are on which side of my equation? They're on the I'm asking up here. Which side of my arrow? Right, so this side is products, okay? I only ask because it's been a while. All right, so this side is products, so I need to look at those first, okay? So first of all, I'm going to go ahead and start with brackets because I know I'm going to have a large sum in here, but I'm going to have multiplication within each sum, okay? So I'm going to have 2 moles, so I'm going to put 2, that's what the NP is for, it's how many moles of something, okay? And then times, and then I look up in table 6.2, let me see here, this is CO2. So we look up CO2, we get negative 393.5. And this is kilojoules per mole. And I realize now this should also be mole. Okay, that should be unit, my bad. All right, and then I'm going to add in the next product, which is 3 moles of, and looking up H2O as a liquid. Some things have more than one state, so be careful. Water especially. So as a liquid, it's negative 285.8 kilojoules per mole. All right, and that's the end of my products, so I go ahead and close my brackets. So far, so good? Okay. Real quick, notice that moles then cancels. And so I'm left with only kilojoules, which makes sense because that's what delta H should be measured in, right? Okay, so that's what's happening. Now, I'm not done. There's another half of this problem. But I'm going to go on to the next line because I'm out of screen. Okay? So this is going to be minus, bracket. All right, now I need the reactants, which is on this side. So in the first one, I only have 1 mole. If there's no number, remember it's an understood 1. Of C2H5OH, which as a liquid has negative 277.7 kilojoules per mole. Again, pulling those from the table on, or table 6.2. If it will load, I can tell you what page, 84. And then the other reactant is oxygen. We have 3 moles of that. And if you start looking for oxygen, you're going to notice that it's not there. And you're like, great, I have every other number given to me except that. But keep in mind, oxygen is what? Huh? No, what did you say? I didn't even hear you. What? I don't know what you're saying. Okay. Anyway. No, what is oxygen? If it's not combined with anything else, what is it? 0. It's 0. It's a free element. So 3 times 0 kilojoules per mole. Okay, you might be like, well, Mr. S is stupid. Why do we have to put that in there? Because it's part of the formula. All right, so that's why. All right, so moles cancels. Not that any of that matters, because it's just going to be 0 anyway. But over here, that one's going to matter more. All right, so As you go through here, you can either start figuring stuff out and simplifying, or you can throw it in your calculator. Personally, I tend to do the latter, but I would note that at the end, you're going to end up just basically, for the second part, you're just going to end up doing plus 277.7 kilojoules per mole because minus the negative. All right, but anyway, with that, then you get a delta H of negative 1,366.7 kilojoules of energy. Now, is that what I was asked for? No. What was I asked for? Okay, so let's stop and think about this for just a minute, because you might start thinking negative and think one way or the other. I don't want you to do that. Let's think through the scenario. Does negative mean it's gaining or losing energy? Losing to its surroundings. So then which is it? Exothermic. It's sending heat out into its surroundings. This is an exothermic reaction. Yes, very much so. You call that an implosion. That's much, you know what, we're not getting into that. Because I don't have time. I mean, I got 7 minutes left of class. All right. Yes, I do. Okay. Now, it is often inconvenient to work with mole amounts of substances. For example, we might want to find out how much heat would be generated by 500 grams of ethanol rather than 1 mole of ethanol. So like this right here, that told us how much we use in 1 mole of ethanol. Well, how much is that? We don't know. Are you going to sit there and count 6.022 times 10 to the 20th? No. Okay, we want to know it in grams. Okay, so let's say we had 500 grams of ethanol. Rather than 1 mole of ethanol, to find it, you would first find delta H per mole. So we've already done this first part, and we're going to do this in the next example, okay? So you would first do this, okay, and figure out how much per mole, and then you would figure it out, and then you would just convert, okay, using molar mass. Okay, so that's the idea. So example, ignore all that. All right, example, yeah, I know. I was real helpful to my past self, hence why I got out this. All right, so I was just like, I'm going to do it on the board. Well, I can't do that in here. The idea was I could leave the previous example up and then keep working. But anyway, oh well. All right, so keep in mind, you might just write down continues from example 6.4 at the top, okay, because we're going to use that number in this, and so that way you know where it came from. All right, so how much heat is liberated in the combustion of 500 grams of ethanol? It's basically see the previous example for all the details, okay? But first thing we need to do, actually really the only main thing we need to do before converting, is we need to figure out how many grams per mole in the first place, okay? So we have, here, we're going to take the molar mass of C2H5OH, whoops. Oh well, that's just going to be a funky size, I can't do anything about it. All right, so this is going to equal to 2 times whatever carbon is. What is carbon? Huh? No, that's oxygen. 12.01. So this is 12.01 grams per mole. Plus 6 times 1.008 grams per mole. Plus, by the way, the 6 times 1.008, we have 5 hydrogen, but then there's a 6th one here. Okay, so we just threw it all in one because it doesn't matter. We have to have it separate to indicate that OH is its own ion, but for the sake of mass, it's not going to change where it is. Okay, it doesn't matter if you're carrying a 50-pound book or it's in your backpack, you're going to weigh the same on the scale. All right, so that's kind of the idea. And then a single oxygen, which is 16 grams per mole. Oops, of course I write that one that way, but we're not getting into that. When we add all this up, we get that the molar mass is 46.07 grams per mole. Okay? So that's the idea. We have 46.07 grams per mole. So now we need to go through and figure out, well, how many moles of stuff do I have then? Okay, because this is how many grams per mole, and I know I have 500 grams. We're going to go through and convert this. So we have 500 grams of ethanol, and I know that it's 46.07 grams per 1 mole. You might ask how I knew to put the 46.07 on the bottom. That's because grams has to cancel. Okay, so I need to get grams to cancel, so I'm going to put them in opposite places. So grams cancels, leaving me with, after the division, 10.85 moles. That may be rounded, I don't remember. Okay, but obviously you would use the unrounded answer in your calculator. Okay, same with all this. Because I think I rounded stuff for the sake of showing my work, but I used unrounded answers in my calculations. Does that make sense? Okay, so just assume that. That's normally what I do. Okay, so then I know how much stuff I have. Okay, I figured out how much stuff per stuff. That made sense. I found out how much stuff per gram. Then I found out how much stuff I actually have based on how many grams I have. Come in. Hi. No? Okay, go ahead and grab it. All right, so then, now what I'm going to do is I'm going to put all that together with the amount of enthalpy change we found in the previous example, and we're going to go through and figure out how much energy is actually produced by 500 grams of reaction right now. Okay? So, we have the number from the previous problem, 1,366.7 kilojoules per mole. Okay? And we know we have 10.85 moles of stuff. Okay? Well, again, moles cancels, and again, we're using unrounded answers for both of these. Okay? And then I find out by multiplying the two together that we have we end up with negative 14,830 kilojoules. Move the cursor. Okay. We have negative 14,830 kilojoules being released in a single reaction if I react 500 grams at the same time. Okay? Half a kilo. No idea. No, it can't be that big. Ethanol isn't that light. I don't know off the top of my head. All right. And that concludes 6.2. I'll see you all tomorrow.
All right. So, quiz on Friday. That's going to be 5.1 to 5.11. For you guys online, again, that's going to be an online quiz. I'm going to send a link to you tomorrow. But today we're going to be on we're going to be on, that's the wrong one. I'll look that up in a second. That's the wrong one. We're on 6.13. So, 6.13. We're on page number 182. Using calories. Using calories. So, a balanced diet involves using calories for heat and mechanical energy as much as it involves consuming them. The number of calories consumed and the number used should be fairly equivalent unless weight is to be lost or gained. Okay? So, if you want to gain weight, you would want to make sure that you're taking in more calories than you're putting out. Okay? If you want to lose weight, it's the opposite. You want to eat less calories and use more calories. Okay? Each person uses a certain number of calories daily just being alive. So just by living, you're using calories. You need to make sure you're bringing that amount of calories in, otherwise you will die. Okay? The table at the right gives the calories expended for basal energy for some weights of men and women. Okay? So basal is the bottom, basically just the amount typically that you're going to need to survive. So women, if you weigh 100 pounds, you need to take in at least 1,200 calories. 120 pounds, 1,300 calories. 140 pounds, 1,400 calories. 160 pounds, 1,500 calories. 180 pounds, 1,600 calories. Guys, if you weigh 140 pounds, you need 1,500 calories. 160 pounds, you need 1,600 calories. 180 pounds, 1,700 calories. 200 pounds, 1,800 calories. 220 pounds, 1,900 calories, okay? Those are just estimates. They could change, or they will change. Okay? On the back, on page 183, there is a calculation or table of what certain activities use as far as calories per minute. So, bowling, when you're actively bowling, you burn 7 calories a minute. When you're chopping wood, you burn 7.5 calories a minute. Cleaning windows. Cleaning windows, you would use 3.7 calories per minute. Hello.
Has anyone seen a pen? Oh, there it is.
This right here?
Yeah, the one that I need for my drawing tablet.
No,
Yeah,
I haven't
is
seen
it
it.
the one?
I haven't seen it at all.
Thank you.
Okay. All right. So again, cleaning windows would be 3.7 calories per minute. Let's see here, some good ones. Walking upstairs is 10 calories per minute. Swimming is 9 calories a minute. Mountain climbing, that's 10 calories a minute. Ping pong is 4.9. Wrestling is 14.4 calories a minute. Football, when you're actively playing, not when you're in between plays, but actively playing, that is 13.3 calories per minute. Let's see here. Sweeping the floor, 3.9 calories per minute. Basically, anything you do, if it requires movement, you're burning calories. You're burning extra calories. Okay? So the more you get up, the more you move, the more calories you're going to burn. That means that the more calories you're going to have to consume if you want to gain weight. Okay? So that is the last section for this chapter. Again, you're going to have a quiz on Friday. Let me double check those page numbers. And that is going to be, this is a little bit better. 6.1 to 6.10. 6.1 to 6.10. Okay, there's your quiz on Friday. Tomorrow, we're going to go over some review stuff. Friday, you're going to take your quiz. Looks like Monday, we're going to take the test. Okay? I don't really like giving tests on Monday, but that's what we're going to have to do. All right? So Monday's going to be your test. That's going to be over all of Chapter 6. So you guys can get started reviewing that, studying that. Your distance learning, you're going to have that test online along with your quiz for Friday. It's going to be online. Other than that, we're going to be done for today. There is no homework, but I would like you guys to work on some problems. So go ahead and work on page 185, 7 through 16. 7 through 16, work on those problems. Other than that, we are done for today.
All right, so in our literature books, go ahead and turn to page number, I believe it is 101. 101, we are talking about authors of Richard Crashaw, Bishop Thomas Ken, and then also John Milton. So go ahead and turn to page 101. Okay. Is the screen on over there? Oh, I thought I tried to turn it on. Okay. So an epitaph was written by Richard Crashaw. This was upon a husband and a wife who died and were buried together. So obviously an epitaph upon a husband and wife. This work paints an ideal portrait of a loving couple whom death could not separate. How sweet is that? Okay, so that is what an epitaph is. You guys just read on through the poem. To these whom death again did wed, obviously husband and wife, this graves the second marriage bed. For though the hand of fate could force twixt soul and body a divorce, so obviously when we die our soul is separated from our bodies, because they both lived but one life. Peace, good reader, do not weep. Peace, the lovers are asleep. So he's telling us not to fret because we're not supposed to mourn these two people's deaths because their souls are together. They, the sweet turtles, folded lie in the last knot that love could tie. Let them sleep on, till the stormy night be gone, and the eternal morrow dawn. Then the curtains will be drawn, and they waken with the light whose day shall never sleep in the night. Obviously, they're talking about eternity in heaven where there is no night. So that is an epitaph. This paints an ideal portrait of a loving couple whom death could not separate. Okay? Look over to the poem now. This was written by Bishop Thomas Ken. He was an Anglican bishop, a hymn writer, a royal chaplain to Charles II. He had different hymns, including Awake My Soul and With the Sun, Glory to Thee, My God, This Night. And then his well-loved doxology, Praise God from whom all blessings flow. So you can thank Mr. Bishop Thomas Ken for the doxology. But in the poem now, this poem basically emphasizes the fact that time passes rapidly. If you obviously couldn't tell from the title, it's talking about obviously the present, because we need to just look at how fast time flies and how we're living our lives. If you look in the past, talking about the past in the first paragraph, the past can be no more, whose misemploying I deplore. The future is to me an absolute uncertainty. The now, which will not with me stay, within a second flies away. Obviously, time flies by so fast. I heard God often say, now of salvation is the day, but turned from heaven my view, I still had something else to do, till God a dream instructive sent, to warn me timely to repent. And this is kind of reference, we obviously see that he is a bishop, obviously a man of the church. We see this actually in the Bible, where the Bible talks about how today is the day for salvation. And now is the time for salvation. And a lot of people in the Bible, they kind of turned away and said, oh, I'll do it later, or I'll put it off. And then the Bible's talking about now is the time of salvation. That's what he kind of is referencing to in the second paragraph. In the third paragraph, he said, methought death with his dart had mortally transfixed my heart, and devils round about to seize my spirit flying out, cried. Now, of which you took no care, is turned to never and despair. I gave a sudden start and waked with the never in my heart. Still I that never felt, never upon my spirit dwelt. 1,000 thanks to God I paid, that my sad never was delayed. And obviously, never was talking about eternal damnation and an eternity without God. And he was thanking God. If you guys look in line number 11, he said, till God a dream instructive sent. God sent him a dream where he had a bad dream, where he had to live separately from God. And he was just thanking God that it was a dream, and that the word never is kind of a reference to his eternal life without God. He's thanking that his never, or his death never came because it was all a dream. So this is just kind of emphasizing time, how it passes rapidly, and that now, in the moment, we need to accept God and live for God. Okay? Go ahead and turn the page to 102. Actually, turn over to page number 109. Before we get into the section about John Milton, let's look at some facts about John Milton, okay? So John Milton, he was a blind author of Paradise Lost, which was England's greatest epic. If you guys want to mark this on page 109 or write it down. He was blind, and he was the author of Paradise Lost, which was England's greatest epic. And if you don't remember what an epic is, it's something with lofty language. There's a great national hero. Paradise Lost has those epic qualities in them to make it obviously an epic. So England's greatest epic was Paradise Lost. John Milton wrote it. He also ranks as the greatest English poet next to Shakespeare. Obviously, he lived during a different time period of Shakespeare, so he definitely was the most outstanding poet of the 17th century. He also wrote England's greatest pastoral elegy, which was called Lycidas, or Lycidas. I don't even know how to spell it, or but that's what he also wrote, which was England's greatest pastoral elegy. All of this is on page 109. If you just want to mark it in your book. He wrote this elegy to commemorate the drowning of Edward King, a former classmate. After a year abroad, Milton returned to England to write his greatest prose. He wrote a number of pamphlets furthering the Puritan cause. The best known of these is Areopagitica, a cry for freedom of the press. And then, after Milton became blind, he produced his greatest works, which were Paradise Lost, Paradise Regained, and then Samson Agonistes. Okay, I'm just going to say that. All right, so that's John Milton and some facts about him. Okay, so you should have read some of his poems yesterday or last night. Go to page 102. Okay. Psalm 1, this was pretty much self-explanatory. It's his metrical version or his metrical verse of the Bible book, Psalms in chapter 1. Okay, I won't take the time to open our actual Bibles and compare it to the King James Version Bible, but this is just the metrical version. It makes it sound nice. Obviously, things rhyme within John Milton's version. Blessed is the man who hath not walked astray in the counsel of the wicked, and in the way of sinners hath not stood, and the seat of scornfuls hath not sat. Basically just changing up Psalm chapter 1 into something that kind of rhymes a lot more. Okay? Song on May Morning. This poem Milton wrote in praise of spring. Obviously in May, he says, now the bright morning star, day's harbinger, which is an announcer or a herald. So obviously spring is kind of like coming per se. He's praising spring. Comes the dancing from the east, and leads with her the flowery May, who from her green lap throws the yellow cowslip and the pale primrose. Hail, bounteous May, that dost inspire mirth and youth and warm desire. We kind of talked about spring in a few poems back, and how it's a picture of youth and warmth, and then winter obviously may be pictured as old, cold, icy, stuff like that. So this is just kind of his praise of spring. He loves spring. He says it brings mirth, it brings youth and warm desire. Woods and groves are of thy dressing. Hill and dale doth boast thy blessing. Thus we salute thee with our early song, and welcome thee and wish thee long. Okay, so he loves spring. Go ahead and look at the top of the page on 103, just the background. Some of Milton's most beloved poems are his sonnets, which he wrote throughout his career. 5 of Milton's 23 sonnets were written in Italian, and he used the Petrarchan sonnet form in all 23. In the sonnets, he expressed his personal feelings on topics about which he felt strongly. On his having arrived at the age of 23, he reflects on how quickly his life is going by and on how little he seems to have accomplished. We see that in on his having arrived at age 23. He's kind of sad that he is already 23 and has not yet produced any great works. He says, "How soon hath time, the subtle thief of youth, stolen on his wing my 23 year. My hasting days fly on with full career, but my late spring no bud or blossom showeth." He's basically saying he hasn't done anything. He's 23 and he really hasn't done anything impactful or important. But obviously, later on, he goes on to write things that obviously we know to be England's greatest epic and a lot of things that we read today. Okay? And then also, on his having arrived at the age of 23, this was his Italian sonnet. And then on the late massacre in Piedmont, this is just Milton's outtake on historical events. He's basically just talking about people who were slaughtered and like massacred, obviously. In Piedmont, he says, "Avenge, O Lord, thy slaughtered saints, whose bones lie scattered on the Alpine mountains cold. Even them who kept thy truth so pure of old, when all our fathers worshipped stocks and stones, forget not, in thy book record their groans who were thy sheep, and in their ancient fold, slain by the bloody Piedmontese, that rolled mother with infant down the rocks." That's kind of gruesome. "Their moans the vales redouble to the hills, and they to heaven. Their martyred blood and ashes, so o'er the Italian fields, there still doth sway the triple tyrant," which is the Pope, characterized by his triple crown, "that from these may grow 100-fold, who, having learnt thy way, early may fly the Babylonian woe." And that's kind of a reference to the corruption of the Catholic Church was often associated with Babylon. And in this, obviously, this is his outtake on historical events that happened. He was very angry about it, but also he kind of alludes to the Catholic Church and their hold that they have on people. So he's obviously saying that those who were slain need to be avenged, and he kind of blaming the Catholic Church on their maybe on their influence that they had on the people. Okay, so back to the background. Just some background on the late massacre in Piedmont. Milton voices his indignation at the atrocities which occurred to the Waldensians, a group of dedicated Protestants living in Piedmont, Italy, who were massacred after refusing to become Catholics or leave the country immediately. So those are his two sonnets that we just studied. Okay, and then the last page is In Defense of Books. In Defense of Books was taken from Areopagitica, which we kind of saw in his background. It was one of the most compelling arguments for freedom of the press of all time. So that's what he kind of wrote, was kind of a voice for his freedom of the press. In Defense of Books, in this, he emphasizes the great influence of books and why we should be careful to preserve them. I know some of you guys really like to read, and maybe some of you guys would agree with John Milton in how books allow us to kind of, like if we're writing books, like books are kind of a window for men to see from our perspective, or maybe it'll influence people of, you know, what they're saying. Books are definitely very influential and important, so that's what John Milton was saying in this work. He says, "I deny not, but that it is of greatest concernment in the church and commonwealth to have a vigilant eye how books demean themselves as well as men, and therefore to confine, imprison, and do sharpest justice on them as malefactors. For books are not absolutely dead things, but do contain a potency of life in them, to be as active as that soul who was progeny, which is an offspring or children they are. Nay, they do preserve as in a vial and the purest efficacy and extraction of that living intellect and that bred them." He's basically saying books are just as alive as the author that wrote them. He goes on to say, "I know they are as lively and as vigorously productive as those fabulous dragon's teeth, and being sown up and down may chance to spring up armed men. So books definitely have influence on people. That's why he's saying, obviously, books are very important. Okay? So those are just some outtakes on John Milton and his works. Obviously, no homework tonight, but then we're going to start reading Paradise Lost. This is obviously the greatest epic in English literature, and John Milton wrote it. He was blind when he wrote it, so we'll go on into detail for that tomorrow. Okay? Go ahead and put those away and take out your grammar books. We're going to talk about voice, since I skipped over that one by accident. So that is on page number page number 67, okay? Page number 67. Give me 1 second. Page 67 in your workbooks. Let's talk about voice, okay? Voice is that property of a transitive verb that tells whether the subject is doing the action or receiving the action, okay? So have we studied what transitive verbs are yet? I'm not exactly sure, but anyway, transitive verbs, in short, are basically words that have receivers, okay? So, for example, if it's an action verb, okay, so maybe throw, okay? So, I threw the ball, all right? Threw is obviously an action verb. It is showing the action of a ball being thrown. Okay, well, I threw who or what? A ball. Okay, so if there is a receiver of the action word throw, which is ball, therefore the kind of verb that the action verb is transitive. Okay, so if it's intransitive, that means there's no receiver. Okay, so another example. She plays the piano. Okay, so plays is an action verb. She plays who or what? Piano. Therefore, plays is an action verb it's a transitive verb, okay? Where plays would be intransitive is if I were to say, she plays well, okay? So, plays is obviously the same verb, but it is intransitive because there's no receiver of what she plays. Yes, she plays well, but it's an adjective or an adverb describing how she plays. Okay, does that make sense to everybody? So with transitive verbs, they have receivers. Okay, so that kind of tells you that transitive verbs can only go with action verbs. Okay, so voice is the property of a transitive verb that tells whether the subject is doing the action or receiving the action. Okay, so let's get 10.32. If the subject is doing the action, the transitive verb is active. Okay, if the subject is receiving the action, the transitive verb is in passive voice. Okay, so look at your examples. A hornet stung Bobby. Okay, stung is obviously an action verb. Is the hornet physically stinging? Yes or no? Yes, it is. So therefore, stung is an active voice. So if the subject is physically doing the action, it's an active voice, okay? However, even if it was an action verb, so look at your example, this next example, was stung, okay? Bobby was stung by a hornet, okay? Is Bobby stinging? Okay, Bobby is my subject, obviously. So, was stung, Bobby is not physically was stinging, okay? So therefore, Bobby was stung by a hornet is in passive voice. The subject is not physically doing the action, okay? It's kind of receiving the action of the transitive verb, was stung. Who was stung? Bobby, right? So therefore, it is passive, okay? Look at 10.33. A verb in the passive voice contains a form of the verb be, okay? Am is our was were be being been, plus the past participle of a main verb, okay? We see that in Bobby was stung. Was is my be form of the verb. Stung is my past participle part of the main verb. Okay? So that's how I know it could be in passive voice. Shall, will, have, has, had are used in addition to be and the past participle of a main verb informing the future tense and the perfect tense. Any verb that contains a form of the be and a past participle is a passive verb. Okay? So that's kind of an important sentence to highlight if you're looking for a passive verb. So make sure you underline that. Any verb that contains a form of the word be and a past participle is a passive verb. Okay? So basically anything was found, had been found. Okay? All of these are passive. Okay? If the subject is not physically doing the action, it is not active, it's all passive. Okay? Look at 10.34. The following is a conjugation of a verb in the passive voice. Okay? So, look at your examples. In first person, obviously that's me. I am seen. Okay? Am I physically seeing? Yes or no? No. Okay? So, therefore, am seen would be passive. Okay? How would I change it to active? Okay, this is kind of venturing out. What would make the word see active? I saw. Good. Okay, I saw or I see you. Okay, see would be active if the subject of I was physically doing the action. Okay, if the verb is not doing, or if the subject is not doing the action of the verb, it is passive. Okay, look at 10.35. When the verb is changed from active to passive voice, the object of the verb becomes the subject, and the subject of the object, or the subject becomes the object of the preposition. Okay, so this is when you're changing from active to passive. Okay, for example, the water damaged their new carpet. Okay, the reason why this is an active voice is because the water is physically damaging their new carpet, right? Okay, so notice how there is your subject, there's your verb, and then there's a DO, right? Carpet. Well, if you're changing to active voice or to passive voice, your object or your complement basically is carpet, obviously. That becomes the subject, and then the subject, water, becomes some type of predicate or something in the predicate. So this is how I would change it to passive, okay? Their new carpet was damaged by the water. Obviously, water is not some kind of object of the preposition, or yes, it is right here, but it becomes part of the predicate or after the verb, okay? So changing the water was damaged to their the water damaged their new carpet, which is active. Changing it to passive, their new carpet was damaged by the water. Obviously, carpet isn't damaging. They're not doing the action. That's why it's passive. Okay? Look at 10.36. An indirect object or a direct object that is retained when a verb is changed from active to passive voice is called a retained object. Okay? Look at your example. In an active voice, it says, my mother gave me a bracelet. Okay? So obviously, mother is my subject. Gave is my action verb. A bracelet is the complement. To whom or for whom, me would be the IO. Okay? So when I'm changing it to passive voice, I was given a bracelet by my mother. Okay? Bracelet would be a retained object because obviously it was changed from the active voice. Okay? My mother gave me a bracelet. Same thing in the active voice. If I would change the word me to a retained object, would be a bracelet was given me by my mother. Okay? So anything that you change from active to passive, the direct object that is retained, that you keep, is called a retained object. Okay? Look at your note. A retained object is diagrammed the same as a direct object. So that doesn't really change there with the diagrams. Okay? Look at 10.37. An objective complement that is retained when a verb is changed from the active to passive voice becomes the subject complement, or the predicate nominative or predicate adjective. The passive verb functions as a linking verb to join the complement to the subject. Okay, let's look at our example. We made Scott treasurer. Okay, obviously we is my subject, made is my verb. We made Scott, right? We didn't made treasurer, we made Scott. So Scott would be my direct object to be treasurer. So treasurer is my objective complement. How I would change that to passive voice, it says Scott was made treasurer. Okay? Then that would always obviously just be a PN. If it's describing the subject, then a PA. Okay? It just depends on your sentence. Okay? Look at page number 70. We consider Scott dependable. Okay? We consider subject and verb. Scott is my DO. To be dependable. Dependable is my OC. That is an active voice. Okay, how I would change that to passive voice. Scott is considered dependable. Okay, obviously dependable is a predicate adjective describing Scott, but then that's what the OC becomes. Okay, OC becomes either PA or PN. Okay. 10.38, in writing, use the passive voice sparingly. You're not always going to want to say, here, let's just read on. I'll give you more examples. Okay, overuse of the passive voice causes a weak and awkward style. However, there are occasions when the passive voice is more natural and emphatic than the active. So your grammar rules, they don't want you to always use passive voice. You're not going to be like, the ball was given to me by him, okay? You're not going to say, the door was opened by me, okay? That's kind of awkward, right? You're always going to say, I opened the door, or he gave me the ball. That's active voice. But sometimes, passive voice is more natural than active. So look at letter A. Use the passive voice if the doer of the action is unknown, okay? So if you don't know who did the action, then you probably want to use passive voice. So example, some products of earlier times have now been replaced. Okay? You can't really tell who replaced the objects, right? So in this example, passive would be a lot better to use. Okay? Same thing. Many fine horses are raised in the bluegrass pastures of Kentucky. Okay? You don't know who raised horses, right? So fine horses are raised would be more appropriate here. Okay, does that make sense to everybody? Okay, look at letter B. Use the passive voice if the object or the receiver of the action is more important than the doer of the actions. Okay, look at your example. Hard-shell clams were used by Indians as money. Okay, I kind of want to talk about more of hard-shell clams. I don't really care about the Indians using them as money, right? My subject is hard-shell clams. That's why I'm emphasizing hard-shell clams rather than Indians use hard-shell clams as money, okay? And then letter C, use the passive voice if you think it better to leave the doer of the action unidentified, okay? So, say, for example, regrettable things were said in the heat of the moment. Okay, if you don't want to give someone up, you want to say, he said regrettable things. Okay, if it's kind of, you just want to leave the subject out or of the doer of the action unidentified or anonymous, then you can just use passive voice. Okay, so let's practice that really quickly. Everyone go to page number 24 in your workbook. Actually, it'll probably be on page 23. Yep, page 23, okay? Voice, exercise 46, okay? So we don't have homework tonight, but let's get through these so we can understand them more together, okay? Number 1, underline the verb or verb phrase in the following sentence. We should already know how to find our verb. In the blank, identify the verb or the verb phrase as active or passive, okay? Then, above each italicized complement, identify it as direct object, indirect object, retained object, objective complement, PN or PA, okay? The only time you're going to use retained objects is if it's in passive, okay? If it's in passive voice. So let's go ahead and look at number 1. Okay, number 1. Everyone at the convention will be given a name tag and a special packet of materials. Okay? What is my verb? Who knows? Good, it is will be given. Okay? Jaylene, can you tell me if will be given is active or passive? It's not active, it's actually passive. Here's why. Is the convention physically will be given? Like, is the convention giving something physically? No. That's why it's passive, okay? When the subject is doing the action, therefore it is active, okay? So, number 1 is passive. Look at packet, okay? What is packet? What kind of complement is that one? This one is actually a retained object, okay? Like I said, obviously now direct objects and retained objects, they're all the same. They get diagrammed in the same one. But like I said, with passive voices, it's all retained, okay? So look at number 2. Dr. Wellborn, a noted economist, is giving a series of lectures on inflation this week. Okay, Noah, what's my verb? Is giving. Good. Okay, is that active or passive? It is active because Dr. Wellborn, the subject, is actually, like, he's physically giving. Okay, what is he giving, class? Series. Okay, so with active, what is series? This one is a DO. Okay, this one is a DO. Remember, retained objects will be in passive sentences. Okay? Ian, number 3. Throughout the campaign, the president has been building up a broad base of support among middle-class workers. What's my subject? Or what's my verb? Good. Has been building. Is that active or passive? Why would it be passive? Not exactly. It's active because the president is physically building or has been building. Okay? So make sure that if the subject is doing the action, it's all active. Okay? So with active sentences, what is my complement? What is base, class? No, with active. It is a DO, okay? Number 3 is active. Base would be a direct object, okay? Number 4, the company was declared bankrupt by the Finance Commission. Do you have a question? Yeah, let's do number 4 really quickly, okay? What's my verb, Kylie? Was declared. Good. What's my subject? Company, okay? Company was declared. So was declared. What voice is that? Active or passive? It is passive. Great. Okay? Because the company is not physically or actually doing the action of declaring. It was declared. Okay? And one thing you can note with that is there is the word was. So there's our be form of the verb. And then declared. There's our past participle form of the verb. So therefore, we can identify that as a passive voice. Okay? Bankrupt. What is bankrupt? What is it? It's not a noun. I'm sorry, I can't hear you. Not a retained object. Okay? Listen, so the company was declared bankrupt. Okay? Bankrupt isn't a noun. It's describing the company. So that one would be a PA. Okay? Number 5. Our neighbor has been named the head of an anti-crime organization in our city. Okay? What is has been named? Emma? Active or passive? It is passive. Good. Okay. There is my be form of the verb been and then named. Okay. The head of an anti-crime organization in our city. What is the word head? It is a PN. Good. Okay, and then number 6, the defendant was found guilty of perjury by the members of the jury. What's my verb, class? Was found. Good. What is guilty? Or actually, what is was found? Is it active or passive? It is passive. Notice how there is the was there. There's my be form, and then found is my past participle form of the verb. Okay? Was found, and then guilty. What is guilty? It is a PA. Good. Okay? So the bottom line for voice when it's active or passive, with active, if the subject is physically doing the action, or if it's performing whatever action it is active. If there is a be form of the verb and then a past participle, so was found or was declared or has been named, okay, all of those have the be form, am, is, are, was, were, be, being, been, okay, plus the past participle, then I know it's passive, okay? All right, we'll practice, we'll review those more later, but are there any questions about anything? Do you have a question still? What's your question? On number 3, you said? Okay, number 3. Right, but the president is still doing it. So he's still building. So that's something that we do need to watch for. But as long as the subject is doing the action, then it is always active. Okay? But notice how building is in the past participle form of it. So building is still happening. So it would be the present. With passive, it would be the be verb plus the past participle form of it. Okay? All right. We'll practice those more tomorrow. Thank you, guys, and have a good rest of your day. For those of you in distant learning, you can turn in your homework. For those of you who haven't turned in your homework yet, was it 7 through 12 last night? Twice. So 7 through 12, twice. For those of you distant learning, please send me your homework if you haven't already. You can put it right there. Thank you. Oh, those are from like the past. You can just put it somewhere on there. Start a new stack. Okay? All right, guys. Thank you guys so much.
All right, welcome to Algebra 2. We're going to get started here. I know I'm running a tad behind, but oh well, you'll live. All right. No, seriously, you guys will be fine. Parallel and perpendicular lines, we're on page 165. We're just dealing with this a little bit. And it's not too bad, but it just helps to kind of split this one up into a couple days. So here's what we're going to do. Two lines in the same plane, are parallel if they do not intersect. For this to occur, parallel lines must have the same slope. Also, parallel lines must have two different intercepts, otherwise it would be coincident, which is just meaning the same line. To determine whether two lines are parallel, obtain the slope-intercept form of each line to compare the values of m and the values of b from the equation. All right, before we go on to talking about perpendicular, let's look at example 4.2h. All right, example 4.2h. And I just realized Chrome is still open. Go away. There we go. Example 4.2h. And we have equation 1, which is 3x plus 12y is equal to 14. And we're given 6x plus 24y is equal to 12. And so we're checking to see whether or not these two are parallel. Okay? So first step is solve both of them for y. Okay? So I'm going to have 12y is equal to negative 3x plus 14. Y is equal to negative 1/4, 3 over 12. X plus 14 over 12, which is going to be 7 over 6. Okay, cool. Right? By what? Oh, okay. Here, then, we have 24y is equal to negative 6x plus 12. Divide both sides by 24, we get negative 1 over 4. Yeah. X plus 2. All right. So first of all, we check to see if our slopes are the same. So my slope, remember, is here. It's mx plus b. So slope is the same, right? Negative 1/4 is negative 1/4. Okay. Then we check the b value. Neither of you guys are green, yellow colorblind, right? Yeah, hopefully. All right. The b value, I forget. The b value, we notice, is in fact different. So they're not the same line, because that's something we do have to check for. And they have the same slope, so therefore they are parallel. Cool? All right. That was part A. Part B, for what it looks like when they're not. We have 4x minus 6y equals 7 and 5x minus 4y equals 13. Okay? And again, first thing we're going to do is we're going to solve both of them for y. So negative 6y equals negative 4x plus 7. Divide both sides by 6y equals 2/3 x. Notice negative of a negative becomes positive. Plus 7 over, no, sorry, minus 7 over 6 because of the negative. So there we go there. This one, we have negative 4y is equal to negative 5x plus 13. Divide both sides by negative 4. Y is equal to positive now 5/4 x minus 13/4. Okay, first thing we do is we check the slope. 2/3, 5/4, not the same thing, not parallel. The book goes ahead and compares B. What's the point? Once you know it's not parallel, why? But, I mean, they're not the same line if that helps. Okay. So that's parallel. Slope has to be the same, different intercepts, so that way we are not on the same line. But now let's consider what if we want to talk about perpendicular. Well, perpendicular is its own weird caveat thing. For two lines to be parallel, M1 has to equal M2. We just talked about that. But for two lines to be parallel, M1 has to be the negative reciprocal of M2, which means it has to be flipped and the opposite sign. Okay, that's what that means. Okay, so this is how we word this. And this can also be worded as M1 times M2 is equal to negative 1. Okay, this is an alternate form of that same sentence. Okay, so let's look at an example with example I. So we have 6x plus 5y is equal to negative 10, and we have negative 5x plus 6y is equal to 24. Okay? So first step again is still solve both sides for y. So 5y is equal to negative 6x minus 10. Divide both sides by 5. Y equals negative 6/5 x minus 2. All right, on this one, 6y is equal to 5y plus 24. Divide both sides by 6. Y equals 5 over 6y plus 24 divided by 6 is 3, yeah? Real quick, no, that's not right. 4. What? It's 4. Basic times table is just me struggling. It's fine. 24, you be quiet. 24 divided by 6 is 4, yes? Okay, thank you. Look, everyone has those days. I've also already taught 4 math classes, okay? I'm done. All right, so first thing we do, actually it doesn't matter. We don't have to check the intercept anymore because there's no possibility of it being the same line if they're perpendicular, okay? So all we have to do is check the slopes. Notice that negative 6 over 5 is the opposite sign and flipped from 5 over 6. So these are perpendicular. If you want to just give me the symbol instead of spelling out the word, feel free, because that's a ridiculously long word. Okay. Now, we can also create equations given a line that is parallel or perpendicular to a given line. But here is the key, okay? When you're done, it has to go back to standard form. Remember that standard form is ax plus by equals c. You can't leave it in slope-intercept form, okay, in the book. So that's what we're going to do here. Okay, so we're going to have to get back to that. So we're going to figure out how to make things parallel or perpendicular. So first of all, let's go ahead and look at example 4.2j. We want a line that passes through 2, 3 and is parallel to y equals 1/4 x minus 2. All right, so if it's parallel, what has to be true about the slope of the new line? Yeah. Right. So I'm going to have 1/4 as my new slope. That's all I need out of the old equation. Okay, so if I have to solve for y to find the slope first, that's great. Do it. But if they give it to you like this, enjoy. All right, so we have the slope, we have a point. Now we can just use what do you think we can use? We have a point, we have slope. Maybe point slope form? Okay, so we have y minus y1 is equal to m times x minus x1. Okay, so y minus the y we're given is equal to the slope times x minus the x we're given. Okay, we're getting the xy values from this point. All right, so first things first, distribute that 1/4. Y minus 3 is equal to 1/4 of x minus 2 over 4 is 1/2. We're going to add 3 to both sides. So y is equal to 1/4 x minus, this would be 6 over 2, so plus 5 over 2, because we're adding. Okay, so plus 5 over 2. That's just 3 minus 1/2. Okay, but I'm not allowed to leave it like this. Okay, I have to go through and convert. So the first thing we're going to do is I'm going to go through and clear my fractions. So I'm going to multiply everything by 4. So I get 4y is equal to x plus 10. Okay, then I'm going to how's that going to work? I'm going to subtract x from both sides and come up here because I'm out of room. So 4y minus x is equal to 10, but x needs to be in front and positive. So we're going to just multiply everything by a negative. X minus 4y is equal to negative 10. This is standard form. This is your answer. The reason why I switched colors here is because this is technically, this is technically the equation of the new line. That's fine, but when we're answering a question like this, we need it in standard form. Okay, so that pink box is where you could easily graph. The green box is the answer you should give. Okay, let's put it that way. So that is your final answer. All right, so that's for parallel. For perpendicular, it's the same idea, except we go ahead and figure out the slope. So let's look at example H. Example 4.2H. We have we're going 7, 12, and perpendicular to y is equal to 3/4 x plus 1. Remember, for perpendicular, what we're going to have to do is make our slope equal to the negative reciprocal. So I'm going to have negative 4/3 as my new slope. That's what I'm going to do here. Okay, so I can go ahead and use point slope form. So we're going to use y minus y1 is equal to m times x minus x1. Okay? Y minus 12 then is equal to m, which is negative 4/3 times x minus 7. By the way, real quick note, if the equation they give you is not in slope-intercept form, just solve for y to get the slope that way. Okay, so just mentioning that. They don't show it in an example, but that will happen at some point, I can guarantee it. So you just solve for y so you have this, and then you can look at the slope. But they were nice enough and gave it to us in the example. All right, so then we're going to go through and distribute that 4/3, so negative 4/3 x plus 7 times 4 is 28, right? Cool. 28/3. Today's a struggle, okay? All right, so then I'm going to need to get to where y equals negative 4/3 x. We're adding 12 to both sides. 12 would be 36/3. So we're going to have 28 plus 36, which is 64. No, I didn't do that on my head. I just looked at the book. Okay. Anyway, but just like terms. All right, so first things we've got to do is clear fractions. So we're going to take 3y equals negative 4. Whoops, I need to switch colors. Okay, again, this is where we could graph a perpendicular line, but for our answer, we should solve for y. So we're going to have 3y is equal to negative 4x plus 64. We're just multiplying everything by 3. We're going to add 4x to both sides. So 4x plus 3y equals 64. Actually, I think that's the answer. Yeah, that's it. I probably could have fit it underneath, but oh well. Okay, that's the answer we should give. All right, any questions? Cool. The rest of practice 4.2, hold on, let me look at my lesson plan. Numbers 23 through 32 green, as well as review 4.2 green. So basically, page 168 and 169, all green problems on those two pages. Okay? So that's what you guys have. You guys also have a quiz on Friday over 4.1 and 4.2. There will be no lecture tomorrow due to the fact that you guys will just have time to work on this assignment. You're going to have, again, the remainder of 4.2. So you had page 167 due today. Tomorrow's work is pages 168 and 169. You got to do all the green problems for the remainder of practice 4.2 and review 4.2. All right? And I will see you guys on Friday for the quiz. All right? Have a good day.